natural logs. But in the real world, not everything is going to be base E. We have lots of other bases. We're going to see how to apply some of these formulas that we've been playing with, but for bases other than E. So homework in this section. To 57 and 63 through 81 dots. This might seem silly, but it's a quick reminder. Some algebraic properties when we're dealing with exponents. Anything to the 0 is going to be 1. Unless it's 0 to the 0, then we don't really know. If our bases are the same, and we're multiplying, we're going to add exponents. If our bases are the same and we're dividing, we're going to subtract exponents. And last, if we have a power to a power, we multiply. So I know everybody here remembers this. Just a reminder. Get a little bit of a review from college algebra. We want to solve for x here. So we got 3 to the x equals 1 over 81. How can I get that x down from the exponent? What do I need to do to both sides?
ln.
Good. Take an ln. That would work. And then what could I do, guys? To solve for x.
Divide.
Divide by ln. So we get ln of 1 over 81. Right, ln of 3. Bless you. You pop this in your calculator, what are you going to get? See what you come up with here, guys. Right answer. So ln of 1 over 81 divided by ln of 3. You get a nice number. What's that? Yeah, you should get negative 4. Good. So we could always do this. We could always take ln. This might be a little bit of overkill here. It might have been simpler if we had rewritten this. Said, well, shoot, 1 over 81. I know that that's the same as 1 minus the negative 4th. So if we could rewrite them in terms of the same base, if 3 to the x equals 3 to the negative 4, then obviously our exponents have to be the same as well. So if we see that, we could jump right to there. If we write them in terms of the same base, that would be a shortcut. If not, no big deal. We can do this process and see what we get. That's going to work also. Let's give this one a shot. Log base 10, the 0.1 equals x. So for one like this, we would need to rewrite this. How can I rewrite this in exponential form instead of logarithmic? Good. Not exactly. Oh, x. Good. Good. So we'd say 10 to the x equals 0.1. So what would x have to be here? So we agree that this is 1/10, right? So 10 to the x equals 1/10. If 10 to the x equals 10 to the negative 1, what would x have to be? Negative 1. Good. Good. It's Guys, a quick reminder, if we had something like this in logarithmic form, let's just say generically it's log base A of B equals X. Rewriting this, I like to tell my college algebra students, go around the world. We start with the base. We go around like this. So I'd say A to the X equals B. Yeah, so being able to jump back and forth will be helpful if we need to solve for X. You can rewrite them and then figure out what X would have to be. Let's take a look at another one that's a bit more interesting. So log base 10 x plus 3 minus log base 10 x equals 1. What are we going to do here, guys? We want to solve for x.
Get the x's by themselves if we can.
Yeah, we're going to need to. So, I mean, right now I've got two logs on the left. They're both base 10, though. So what can I do since they're both base 10? Yeah, let's combine them. So on the left, this would be like log base 10 of what? Good. X plus 3 over x. So we're subtracting. It's like dividing. That equals 1. All right. So now we have something that's written in terms of a single log. We could basically go around the world again. So this would be the same as 10 to the first equals x plus 3 over x. So 10 to the first, just 10. How would I solve this? What am I going to do? Yeah.
Wouldn't you like x divided by x and 3 divided by x?
No, even there's a better way. Yes, multiply both sides by x. I can multiply here by x, here by x. So I would get 10x. So it equals x plus 3. What's the next step?
Subtract x.
Yeah, subtract x, so 9x is 3. So what's x going to be? 1/3. Believe it or not, if we put a third in here, yeah, we're going to get the right answer. It's going to work.
Why is it 10 with the 1?
Because of the rule that I put up here. If we have log base 10 of something equals 1. A log base 2 of x equals negative 8. See what we get here. Any ideas, guys? Yeah.
You could do the whole 2 to negative 3 equals x. I like it.
So we just have to rewrite this. 2 to the negative 8 equals x. And you have 1 over 256. That'll work. All right. This is sort of getting us back into the swing of things. So you'll see a few questions asking you to solve for x in the homework. You probably won't see it on the test. Again, this is like college algebra stuff. We should know how to do this, but just a reminder. So then, what are we going to be doing? Well, we're going to be taking derivatives and integrals. Let's look at some derivative formulas. dx, where now a isn't necessarily e. This is going to be equal to the ln of a times a to the x. So you can see if a was e and we had an e to the x, we know the derivative of e to the x is e to the x. That would still hold here because ln of e is going to be 1. So this is like, instead of not the more general form, instead of the specific case for e to the x. Second one, we have the derivative of a to the u. Well, this is going to be ln of a to the u prime. Which should make sense. I mean, we're just adding an ln of a here. That's it. We have the derivative with respect to x of, so instead of ln of x, maybe we have log base a of x. Well, this is equal to 1 over ln of a times x. So again, we know the derivative of ln of x is 1 over x. And now when it's base a, you have to have an ln of a factor on the bottom. And fourth, derivative with respect to x, log base a of u. What do you guys think this one's going to be? What's the derivative of ln of u? U prime over u. So now log base a of u, well, we're still going to have a u prime over u. The only thing that's different is we're going to have a 1 over ln a in front. So these are basically the exact same formulas we've seen, except that there's an ln of a in front of all these. That's it. This is going to be a little bit more general, as opposed to just dealing with base e. See what we get for this one, guys. I'm not even going to say anything. Just give us a shot. Y equals 2 to the x. You're going to use number 1 here. See what we get. A is going to be 2. Let's go to the next one. Guys, we're going to get for an answer here.
Ln 2 times 2x.
Yeah, exactly. So here we can notice that a is going to be 2. So if I have a derivative for a function a to the x, well, the derivative is going to be ln of a times a to the x. And just to note, guys, this wouldn't be like ln of 4 to the x. No, it's ln of 2 times 2 to the x. So we just leave the natural log of 2 in front. Good. So far, so good? Okay. Let's make it slightly more interesting. So we had y equals 3 to the 4x squared plus 1. Guys, what would our base be here? 3. So what case would we use? 1, 2, 3, or 4?
2.
Number 2, because now we don't just have x as our power, we have a u. So u here would be 4x squared plus 1. Looking at number 2, I need a u prime. So what would u prime have to be? 8x. And we put it all together. In front, we're going to have an ln of a, so ln of 3, Then we're gonna have an a to the u prime. So 3, 4x squared plus 1 times 8x. I mean, we could leave it like that. I'm a little bit particular. I mean, if it were me, I would write it as 8x ln 3. And times 3 to that power. But again, if we want to leave it the other way, that's fine too. Just be careful. I mean, this isn't ln of 24x or anything. Ln of 3 is its own term. It needs to stay by itself. Cool. Does letter B make sense, guys? All right. Try this one. See what y'all think. Say here y equals log base 10 of cosine x. Cosine x, this would have to be like a u. So if u is cosine x, what's u prime? Good, negative sine x. Good guess. So we take the derivative. The derivative of log base a of u is 1 over ln of a. So 1 over ln of 10 times u prime over u. Negative sine x over cosine x. And again, here, if we want to leave it like this, this is perfectly acceptable. This would be like negative 10 if we wanted to write it as negative tangent x over ln 10. That would work too. That would be perfectly acceptable. Okay, so there'll be some wiggle room on your answers depending on how we want to simplify them. It's good news for you guys. For me, I just got to look a little bit closer at grading them. Not a big deal.
What would the question be for these kind of like questions with formulas? Is it just like 5.5 and then what would be like the question?
It'll just say derive.
The what?
But it's not going to say, I mean, it's not going to say this is section 5.5. It would just say something like this, and it would say derive. So what's y prime? Yeah. So it'll just ask you to find the derivative. It'll give you the function. A, B, C, D. Let's take a look at this. So y equals log base 3 root x over x plus 5. So guys, how do you think we're going to deal with this one?
Using the fourth rule.
What's the fourth rule? Quotient rule. So Miguel, you're partially correct. I mean, I think we are going to need the fourth rule to an extent. But this is ugly, guys. So what can we do with this log of a quotient? Yeah, let's split it up into different parts, just like we did when we had natural log of some ugliness. We split it up into different parts. So let's think of this as 1/2 log base 3 of x minus log base 3 of x plus 5. So 1/2 because it was a square root, minus because we were dividing by x plus 5. And now we can just take the derivative of this guy, take the derivative of that guy, and subtract it on the bottom. See what we got for this one, guys. Take a few minutes, give this a shot, do each part. Looks like we need rule 3 for the first part, rule 4 for the second part. our derivative, well, the 1/2 stays. You know, I have a log base A of x. Derivative of log base A of x is 1 over ln A times x. So 1 over ln 3. So 2 ln 3 times x in the bottom, and then minus. We're going to have an ln of 3 here. In this case, this would be like u. What would u prime be? 1. That's all. Do I need a plus c here, guys? No, good. Good. We're taking derivatives also. That will work. We could leave it like that. If we wanted to pull out a 1 over ln 3, I mean, we could. I'm cool with you guys leaving it just like this, though. That would be fine. Good. Just like we had seen previously, for some of these, it's going to help us if we expand them, rewrite them, and then take the derivative of each part. All right. So let's shift gears a little bit before we take a look at our integration rules. So as far as derivatives go, we've seen a lot. We've seen how to take derivatives of constants, x to a power, u to a power, trig functions, logarithmic functions, exponential functions, etc. One thing we haven't seen, though, I don't have to copy this down, but what if I have like an x to the x? Now, one idea would be to say, okay, yeah, no, we've seen this. We bring the power down and times this to the 1 less power. So we might think about doing something like this. But guys, what would x times x to the x minus 1 equal?
X to the second to the x minus 1.
I mean, would we agree that this is x to the first? Would we agree that these are both base x? So what would this be if I add my exponents? Yeah, so I mean, the derivative here would be x to the, no, that ain't right. So something's off here. The issue is, we don't have any formulas. I mean, this general power rule, this just works if our powers are numbers. I mean, if it's a constant, yeah, we could work with it. But a function to a function, we can't deal with as it is right now. But there's help, it's just waiting off on the side. We have something called logarithmic differentiation. So we use this when we have a function to a function. So let's say if y equals f of x to the x, or if y equals g of x to the u, something like this, where we have a function to a function power. We're kind of stuck here. We can't do anything. So what we do is ln both sides. Then solve for y prime. Or derive and then solve for y prime, I should say. So another trick or another method for our toolbox. If we ever have a function to a function, well, we can take the natural log of both sides and use logarithmic differentiation to get y prime. So we'll look at a simple example first. Say y equals x to the 2 over x. There's nothing really nice that we could do here. I can't call that x to the u and get anything meaningful. So what we're going to want to do is ln both sides. So on the left, I'm going to get ln of y. On the right now, when I take the ln, the 2 over x hops to the front. And I would get 2 over x times ln x. Now this we could kind of work with. We could use a product rule on the right-hand side now. So guys, if I take a derivative of the left, what am I gonna get? What's the derivative of ln of y? Y prime over y. It's like we have ln of u. The derivative of ln of u is u prime over u. It's just u is y here, that's all. All right, what rule do we need for the right-hand side? Yeah, we're gonna have to use the product rule here. We got u, we got v. So u is 2 over x. What would u prime be? What's that? Good. Negative 2 over x squared? I like it. And if v is ln of x, what would v prime be? 1 over x. Good. So we'll put them together. U prime v plus v prime u. Negative 2 ln x over x squared plus 2 over x squared, v prime v, v prime u. And what were we looking to solve for here, guys? Y prime. Did we do that? Are we done? No. So before we go too crazy, what can I pull out from the right-hand side to simplify? Anything in common here? Yeah, let's actually pull out a, let's pull out a negative 2 over x squared. We're going to be left with an ln x minus 1. So we pulled that negative 2 over x squared out, so this would simplify a little bit. So rewriting this, we've got y prime over y equals negative 2 over x squared times ln x minus 1. So now we want to multiply both sides by y so that we can actually solve for y prime. So y prime is negative 2 over x squared ln x minus 1. And guys, what was y equal to?
X to the 2 divided by x.
Good. X to the 2 over x. 2. Do we want to write this? Where do we want to be? Yeah, we can just leave it like this. I think that would work. I realize some people may have brought the x here. We put a negative 2x to the 2 over x squared. Whether or not we brought this part up front or left it in the back, either way is going to be okay. Questions here, guys? A little bit. What's up?
No, you.
I got you.
Do you have a question? Were you here?
I'm fine.
No. Let me put another one up, have you guys work on it, and see what we get. So y equals x to the x minus 1. So same deal, use logarithmic differentiation, rewrite it, and then derive, see what we get. Same deal here, guys. You're going to want to use the product rule then, just like the previous one, after we rewrite it. X minus 1, parentheses, ln x. So anyone stuck or has a question, throw up a hand, I'll be glad to help. Yeah.
I think you got this
Yeah, that's you, that's it. So if you want to pass that around, and if you're interested, guys, just put your name on it, so Dylan, or your email address, so Dylan can send you a link. Guys, the derivative of ln of y, well, that's going to be y prime over y. Here we got to use the product rule. So u is x minus 1. What would u prime be?
1.
V is ln x. So v prime would be
1 over x.
good. Let me put them together. U prime v is ln x. V prime u, well, x minus 1 over x. So far, so good. Next thing we want to do is multiply both sides by y. So these y's cancel. We get y prime equals ln of x, x minus 1 over x times y, and y was x, the x minus 1. And again, I would just leave it like this. That's perfectly fine. This would work as our answer.
Like 1.
I'm sorry?
Where is x over x? You're not returning to 1.
I sort of see what you're saying. So what we could do, if we distributed it, we could say x minus 1 times ln x, and then plus x minus 1 over x times x. So here, we could cancel these two x's. If I had an x and I dropped it by 1, this now wouldn't be x minus 1. What would this be? X minus 2. So we could say, if we wanted to, y prime equals x, x minus 1 ln x, plus x minus 1 times x to the x minus 2. Arguable which one we think is more simplified, quote unquote. Either one of these would be acceptable though. Yeah, just keep in mind, if we do cancel these x's, we're going to have to drop it down by 1. And it would be an x minus 2. Cool. Again, there'll be some wiggle room. Just make sure you guys show your steps on the test if I put a question like this. As long as I can follow it, and you're following algebraic rules, and we get some answer, that's fine. Yeah,
I know we don't have to do that minus 2, but how did you get the minus 2 part? That's one.
gotcha. So we have x to the x minus 1 over x. Well, this is an x to the 1 in the bottom. And when we subtract exponents, or when we divide exponents, we subtract them.
Yeah.
So x minus 1 minus 1
Oh, gotcha.
would
Okay.
be like an x minus 2.
Makes sense.
Yeah, no worries. Good questions. Yeah, Tony.
I don't get the part where, like, after you cancel off the y, what do you do after to make the y x over?
I put a box around it. That's all I did. Yeah. So I multiplied both sides by y, and I said y is x to the x minus 1, because that's what y was.
Oh, okay.
And then I put a box around it, because we're done. Yeah. Other questions, guys? So we played around with derivatives. Bless you.